Hi everyone, how are you doing today? I hope everyone is fine and you are enjoying the moments. Today I have chosen the most important topic, that is significant figures. You can see in your textbook you have the significant figures as subtopic in the first chapter, that's number 1. But its application is in every chapter, because whenever you are doing the calculations, in calculations you will get the numbers, decimal numbers like 3 4 5.6789, then you have to write the answer correct to 2 decimal places, or sometimes correct to 3 significant figures. So here we will try to understand what are the significant figures, what are the rules to write the significant figures, how to find the significant digits in a particular number. That's what I'm going to explain in this video, and I hope you all will enjoy this video. Let's have a look, understand and focus on the topic and learn. It's very easy, it's a fun. You can see the most easiest subject if you will do the practice, if you will learn. The most important plus the most interest subject is only the mathematics in the universe or in the world. Let's start the topic significant figures. We will start with an example. For example, I have a piece of wood, it's 10 centimeter long. Now my friend is asking me, cut the piece of wood, and he is giving me the measurement. The measurement he is giving me 32.567 mm. And he is saying me that I want the exact measurement. The piece you will cut down, it should be of this measurement, that's 32.567 mm. But if I will check my scale, the scale which we have in geometric box, there we have the smallest unit, we have mm. Like we can say 1 centimeter, 2 centimeter, 1.3 centimeter, like 1.3 centimeter. That means 1 centimeter and 3 mm, that is 13 mm. And I can say there is 15 mm. But after this decimal, we don't have there the units. So what I will do, I will take only 32 mm, that is 3 centimeter and 2 mm, 3.2 centimeter. Like this, I will take 3.2 centimeter. I will cut this wood. You can see from this example, I removed these 3 numbers. Why I removed these 3 numbers? Because I don't have there the scale that can measure the fraction of the mm. That is only the reason we have removed it and we have written it 32 mm, that's 3.2 centimeter. From this example you can see we have rounded off this. This means this has been rounded off. What does that mean? It means I have taken only the 2 digits, that's 32. So this 32 is kind of degree of accuracy. Degree of accuracy. You can see here I have removed 3 decimal places. That means I have taken only the 32. I will give you one more example to understand the degree of accuracy. What is actually the degree of accuracy? It is the measure of how close and correct this value is. This value is close to, correct to the actual value. How close is this to the actual value? Close and correct. That means degree of accuracy. What does it mean? The value we taken here, how close and correct is this value to the original value, to the actual value. That's called the degree of accuracy. I will give you one more example. If I have 32.567 centimeters, And same case is here. You can see, if I will take the three numbers like this, 32.5 for example, and in second case I will take 32.56, two numbers. So in both the cases you can see here, I have taken the first three number, I have rounded off it, and I have rounded off it here. I have taken the four numbers. So you can see here, in this case, degree of accuracy will be less than this. Here degree of accuracy will be more. So this is simply the degree of accuracy. So we are using the significant figures in order to write the values correct to their actual value. This is called the degree of accuracy. Here why I am writing 32.5 only? Because maybe I have the instrument, or I can say I have the scale that can measure up to only 5. That's 32.5 centimeter. Why I am taking here the value this? Because I can measure here till this 5.5, and it is the fraction of here it is the fraction of centimeter, 0.5, but here 0.5 is the fraction of centimeter, but this 6.06, this is the fraction of mm. Maybe here I have the possibility of scale, the measuring scale, that's why I have taken here. But you can see, if we will compare with the degree of accuracies, here the degree of accuracy is less than this, here degree of accuracy is more. Now coming to the main topic, that is significant figures. These degree of accuracies are designated by the decimal places, or they are designated by the significant figures. What does it mean, significant figure? We can see, I will show you the example. For example, I will write here the number 1, 2, 3. I will ask you how many significant figures are there. I will say in this digit there are 3 significant figures. One more example I will give you, 15.34. How many significant figures are there? There are 3 significant figures at 3 SF. Here decimal places. How many decimal places are here? That is the numbers after decimals. How many? No, it's 0 decimal place. And here I can see how many decimal places I have. I have 2 decimal places here. One more thing, if I will write 0.56, how many significant figures are there? 2 significant figures, 5 and 6. That is 2 significant figures. How many decimal places are there? That is 2 decimal places are there. You can see from this example, from these examples, 3 significant figures but 0 decimal places. Here what we are saying, 15.34. Here how many significant figures? Sorry, it's 4 significant figures and 2 decimal places. Here 2 decimal places and 2 significant figures. Now you can see, sometimes we will purchase a thing whose cost will be like 101. But what I am saying, you can see here, if any friend will ask me what is the cost of that thing, I will say directly it's 100, because I will not say 101. Why? I am rounding off this 1 to the nearest 10 or to the nearest 100, I can say. So this is the significant figure I am using here. You can say, if I have 123, same example. I have purchased a book whose cost is 123. So what I will do here, if somebody will ask me what is the cost of that book, and I will say, no, it's 120. I am rounding off it. I am taking the significant figures. That is 120 I am writing. So what I am doing, these things we will learn in the exercise, what I did here. But I only want here to make you understand that here it is 123. 123 we can write 120. We are rounding off. When we are rounding off, it means I am writing this number corrected to two significant figures. Actually, the answer is this. I am writing this number corrected to two significant numbers or significant figures. One more thing is there. If I am writing 123.1256, if I will write its answer 123.126, for example, generally I will take here, I will write here 151. So I will write this answer 123.12. You can see here. So what actually is this? Here I am writing only the two decimal places, or simply I can say here I am writing this number up to two decimal places. One thing. Second thing, I am writing this number corrected to 1, 2, 3, 4, 5 significant figures. If I have to say the answer in significant figures, then what I am doing, I am writing it corrected to 5 significant figures. If in decimal places, then I am writing it in corrected to 2 decimal places. That is it. Now we will understand what are significant figures in a number, what are the rules, so that we can understand in a particular number how many significant figures are there. Now you can see there are 3 rules for the significant figures. First thing is there, first question I have raised here, how many significant digits are in a particular number. First we will see how to calculate the significant numbers. You can see, if I will give you the number like 2, 3, 4, 5, 6, 7, 8. How many significant figures are there? You have to count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there are 7 SF. 7 significant figures. You can see the rule 1, non-zero digits are always significant. Non-zero, it means without zero. First rule, all the numbers are significant figures. If it is 234.156, see here, count the number 1, 2, 3, 4, 5, 6. So how many 6 significant figures are there? If it is 0.56789, simply you will calculate 1, 2, 3, 4, 5. So 5 significant figures are there. So the first rule is non-zero digits are always significant. So whenever you will see the non-zero digits, these are always significant. Rule number 2, any zeros between 2 significant digits are significant. For example, if I will write 202, you can see the 0 between the 2 significants, this is significant. So there are 3 SF, 3 significant figures. One more, I will write 123.001. You can see these zeros are between significant digits. So these are also now significant. 1, 2, 3, 4, 5, 6. So here are 6 significant figures. And one more example I am giving. If I will write 0.671003, you can see these zeros are between significant digits. So these are significant. 1, 2, 3, 4, 5, 6. So I can say here are 6 significant figures. And few more examples I will give you. You can see the rule number 3, a final zero or trailing zeros in a decimal portion are significant. For example, I will write here 2300. It is a final zero. You can see here 2 zeros are there. So I can directly say there are 4 significant figures. And one more example I am giving here, 54.300. You can see here how many significant digits are there. A final zero or a trailing zeros in a decimal portion are significant. It means After decimal, you can see this is the decimal portion. The final zeros, these are also the significant. So 1, 2, 3, 4, 5. 5 significant figures. Now the question arises, which are not the significant figures? If I will give you the example 0.0012, you can see these zeros are starting in the number. You can see they are not falling in this condition between the two significant numbers. They are not falling in this condition. So these zeros cannot be counted as significant figures. There are only two significant figures. If it is 0.000101, you can see this zero is between two significant digits. These zeros are not between. So here are only three significant digits or significant figures. Now you can understand this. When is the condition? In which condition we are not counting the numbers, the zeros, as significant figures? When they are like this, 0.00023001. These zeros will be counted as significant digits because they are between significant digits 3 and 1, non-zero numbers. So I can say 1, 2, 3, 4, 5. There are 5 significant figures. I hope you have understood this. Understand this once again. If you are not understanding, there is a doubt, please repeat the video and see it. Watch it.